In this video, we're going to have a look at linear equations and how to solve them. There's two major ways to solve them. Either you're going to do it algebraically by calculating, or you're going to do it by using a graph, which is going to be for later. Alright, first of all, algebraically, we're going to solve 4x is equal to 72. So when we're solving an equation, we're looking for x. 4 times x is 72, so we're going to divide by 4 on both sides. 72 divided by 4, that will give you 18. Alright, so x is 18. Now, then x divided by 3 is equal to 11, and you're going to multiply everything by 11. So you get that x is equal to 32. Alright, that was quite easy. Now, have a look at the next one. Solve the following equations. It's a bit more tricky because we have fractions in here. Alright, first off, you have x plus 4 over 6 is equal to 3. Well, we're going to have to multiply by 6 to get to 3. So, or to get to 6 times 3. So we get this. We multiply both sides by 6. Then, of course, I get 18 on this side. X plus 4 is equal to 18. So x is going to be 18 minus 4. Because we need to deduce 4. Or deduct 4, sorry. 18 minus 4 is 14. Let's have a look at this one. I'm going to rewrite it just to make it a bit neater. 4 times x plus 4 is equal to 18. Alright, so I'm going to get rid of the brackets first. I'm going to get 4x plus 16 is equal to 18. So 4x, I'm going to get rid of the plus 16, so I'm going to minus it. This should not be new, guys. 4x is equal to 2. So x is going to be 2 over 4. So x is going to be a half, or 1 over 2. Okay, so solving linear equations, it's quite okay. Alright, let's have a look at another example. You now get two equations with x on both sides. So you can say this is an equation and then this is one. Alright, so we have two parts. Now we have x here and we have an x here, so we have to be a bit careful. Alright, let's move. Again, we're going to solve it algebraically, so we're going to find x by calculating. So we're going to move all the x's to one side. I'm going to do minus 3x, and we're going to leave all the numbers on this side. So I'm going to minus 2, which is 3. 4x minus 3x is 1x, or x. So x has to be 3. Alright, and this one, 4x minus 4 is equal to 10 minus 3x. Again, we have both x's on both sides. So I'm going to put the 3x on the other side. So I'm going to plus 3x. And I'm going to plus 4 because I have a minus here, so I have to plus 4. So 7x is equal to 14. X is going to be equal to 2. Alright, so far so good. This is not supposed to be new, guys. If you're completely unaware of what I'm doing right now, then I advise you to watch another video. One of the previous ones. Alright, now, so far we've only been solving graphs, or solving equations graphically. Algebraically. Now we're also going to learn how to do it while using a graph. I've told you before that graphs are actually equations, and equations are actually always on a graph. Now, we're going to have a look at these two here. You have the left side, which is 4x minus 7, and the right side, which is 9. Okay, I can solve this algebraically quite easily, but I want to use graphs. So I'm going to split these two up, and I'm going to make them separate equations. I'm going to say, okay, y is equal to 4x minus 7, and y is equal to 9. And how am I going to solve this? Well, I'm going to plot them on a graph. So again, we've done this before. I'm going to plot y is equal to 4x minus 7 on a graph. I'm going to pick x and y. And from the previous video, you should know that when you plot this graph, the y-intercept is already going to be minus 7. Remember? Yeah? This is the c value, or the y-intercept. So minus 7 is over here. Minus 7. So I already know that it's going to have to go through that point. Now let's have a look. Let's pick some random numbers. Let's say if x is 2, what do you get? Well, you get 4 times 2 minus 7, which is 8 minus 7, which is 1. So when x is 2, y is 1. And let's pick another one, a third one. When x is 4, just to make sure, that's 16 minus 7, which is going to be 9. So I have 3 points now. I have my y-intercept here, right? And I have 2, 1. So I'm going to plot that 2, 1 here. 4, 9. like that, and I am going to draw that line. It should look somewhat like this. Let's have a look. When you draw the line, yeah, you move it around a bit. Obviously you guys can be a bit more accurate, you guys have pencils, and like that. Okay, it's important that you don't forget to label your graph. So you drew it on, so it's going to be y is equal to 4x minus 7. Okay, now we need to also plot y is equal to 9. Where will that line, or where will that graph be? Well, it's quite easy. Y is equal to 9, so that means that here on your y-axis here, you have to have a straight line or a horizontal line, and that's going to be here. So this here is going to be y is equal to 9. Let's also give that a name. Alright, now I plotted my two lines. The question is now you have to solve these. The original question was you have to solve the equations. So when, you have to wonder now, when is 4x minus 7 equal to 9? So when are these two equations exactly the same? Or in other words, for what x coordinate will they have the same y coordinate? That's what you're looking for. So they need to have the exact same x and the same y coordinate. Where will that be? Well, obviously here. The point where they cut, or when they intersect, in that point they have the exact same y and the exact same x coordinate. Okay, so that's going to give you the answer to your equation. For what x will y be the same? Well, obviously when x is 4, those two equations will have the same y value. Okay, so the answer is x is equal to 4, solving it through a graph. Okay, good luck guys.